Are you using infrastructure as code and you're curious about continuous integration and testing? Well, then this is the video for you. What's up, everybody? This is Ned Bellavance, Ned1313 on Twitter, and let's talk about continuous integration and infrastructure as code. Now, I know if you've been tinkering around with infrastructure as code, you might not come from a software development background. So you've heard the term continuous integration, but you're not sure exactly what it means. So let's clarify that first. When we're talking about continuous integration in software development, we have to think about where you're storing your code. It's typically being stored in a version-controlled repository. And that repository typically has a default or a main branch that represents the code you actually want to run in production. Now, in the case of infrastructure as code, this would be the code that you actually want to use to deploy the infrastructure that your production code would run on top of. Now, when you want to make a change to this code, the typical workflow is to create a feature branch based off of that main branch, make your changes in that feature branch, and then request to merge those changes back into the main or default branch. When you do that, that is continuous integration. You're continuously making a short-lived feature branch, testing your changes in that feature branch, and then requesting to merge that change back into the main branch. So that's all that is to continuous integration. It's a relatively straightforward concept. Now, how does that apply to the world of infrastructure as code? The main difference between infrastructure as code and typical application code is the fact that application code is about creating executable code that can run somewhere, whereas infrastructure as code is more focused on creating resources. So while there are definitely some parallels between the code development process for each, there are also some unique aspects you have to bear in mind. Now, how does this apply to continuous integration and, more importantly, the testing of your code before it's accepted into the main branch? Well, some of the commonalities between infrastructure as code and application code is stuff like checking the formatting on your code. Is it proper? Is the syntax correct? And is the code logically valid? In the case of application code, that is, does it compile? In the world of infrastructure as code, it is, can I run a successful plan and see what resources are going to be created? So that's some of the parallels. Where the differences lie is the fact that you're not actually creating a build artifact. You're not creating a binary or a set of executable scripts from your infrastructure as code. You're actually creating resources. So what do you want to do before you create those resources? Well, you might want to scan the code to make sure that it aligns with any policies you have in your organization. And another thing you might want to do is run a plan of what's going to be deployed and make sure that the proposed new infrastructure lines up with what you expect and also continues to adhere to those policies. Why don't we walk through a workflow of what it would look like to do continuous integration with infrastructure as code? In a typical workflow, we have a few different components. Let's start with the version control repository, because that's probably the most important part of everything. We're also going to have a workstation where we're doing our local code development and a target environment where our resources are going to be deployed. Now, the first step in the process would be to pull down a copy of that repository to our local workstation. Then we would create a feature branch, make the code updates that we want, and then commit that change and push it back up to the centralized repository. Now, before we do that push, we probably want to do some pre-flight checks on our code to make sure that the syntax is correct and that it's logically valid. And we can do that by running pre-commit hooks on our local workstation. These are essentially helper scripts that run when you try to commit your code to make sure that the code is valid based off of these checks. Now, once the code is uploaded, we also want to check this new branch to make sure that it is valid, formatted correctly, and all those kinds of good things. We want to trust that the person doing the work on the workstation did all this, but also verify that they did. And we can add some additional steps if we want. So when code is uploaded to this repository, we can run some continuous integration validation directly on that repository. Now, if everything looks good from there, the next step would be a pull request to merge those changes into our main branch. And when we issue that pull request, that's our opportunity to run a plan to see what changes are going to be made and then validate those changes. Now, in order to actually run that plan, we're going to need stuff like values for our variables and somewhere to store our Terraform state and some cloud credentials for where we're deploying our stuff. And we might not want to store all of that in our source control repository. In fact, we probably don't. So we can leverage a third-party service, something like M0, to host that portion of the process. So that's what we're going to see as we now walk through a demonstration. Let's start the demonstration from my local workstation. I've got Visual Studio Code running here, and I've already pulled down the contents of the repository we're going to be working with. If you're interested in trying this out for yourself, you can find it on my GitHub account. It's ned1313, and the repository is called m0-ci-example. Now we're going to be making some changes to this code, so I've already created a feature branch called add tags. And now I'm going to make some changes to the code. Now what this code actually does is deploy an Azure resource group, an Azure virtual network, and a virtual machine in that network with the accompanying resources. And when I wrote this code, I forgot to add tags to some of the resources. Oh no! So I have this new feature branch called add tags, where I'm going to be making those changes. So let's go ahead and make a change here. I'm going to add the tags attribute to my Azure RM public IP address, and I'll set it equal to a local value I know I already have called local common tags. But let's say I mistyped it and instead put down local.common tag. Now I've got two problems with my code. One, it's not formatted properly, and two, I'm referencing a local value that doesn't exist. I would love for my pre-commit hooks to catch that and help me out. Now, fortunately, I have some pre-commit hooks, and those are in the file .precommitconfig.yaml. So I'm going to click on that and take a look at what's in there. If you're interested in setting this up on your workstation, I've linked a blog post down in the description from a good friend of mine who wrote about how to set all of this up. Now, what we're actually doing here is pulling some pre-commit hooks down from two different repositories. One is a repository that's for Terraform docs, and it runs the Terraform docs command with a few additional arguments. And the other one is from the GitHub repository from Anton Babenko called Pre-Commit Terraform, and I think you can guess what that repository does. The hooks I want to use from that repository are Terraform format, tflint, validate, and tfsec. If you're not familiar with tflint, it just checks the linting of your code, and tfsec actually it does a static analysis of your code based off of some predefined policies. So I'm going to be running all of these hooks when I try to commit my change. So let's try to commit that change. Over in my source control area, I know this is going to fail, so I'm going to put fail commit in the commit message and click on commit. Once I click on that, it kicks off all of these pre-commit hooks that I've identified. And if we look at the command output, we can see first that Terraform FMT failed. But as part of the failure, it does actually fix the formatting for you. So if we go back and look at main.tf, the formatting of the tags argument is now correct. The other error it came up with is during Terraform validate, and it says, common tag is not a local value you've declared. Did you mean common tags? Because that seems pretty similar, and in fact I do. Now it's not going to make that change for me. That's something I have to do myself. So I will change this to common tags. There we go. And now when I have made that change, I actually need to stage that change. And because Terraform docs ran, it also updated the README a little bit. So I have to stage that change as well. Once I have my changes staged, I can change this from fail commit to pass commit, because I know that's what it's going to do, and maybe a little note here, add tags. Okay, let's try committing again, and this time all of my pre-commit hooks should pass, and this should change from commit to publish branch. So now I can publish my add tags branch up to GitHub, and that will kick off the next series of actions. In the GitHub repository, I have pushed this add tags branch up, and it's letting me know on the main page that there is a new branch that has some recent pushes. Now, the push of that branch is going to kick off a GitHub Actions workflow. If we take a look in the code of git.github/workflows, it's going to kick off this feature branch CI workflow. Let's investigate what's in there. Now, first off, the trigger for this workflow is any branch that is not main. So that's what's going to kick it off when there's a push to any branch that's not main. And the important stuff is a little further down. We're going to install Terraform on the runner, and then we're going to initialize Terraform, run a formatting check, run a validation check, and run tfsec. If any of those fail, then this workflow fails, and we'll see that in the history for this particular branch. Now, fortunately, if I go to actions, I know since I did all those pre-commit hook checks, that these checks are also going to pass. But we can't trust that every developer is going to follow this workflow. So this is a trust but verify type of situation. So if we look at the actual workflow, I can see everything passed within that workflow, and I can dig deeper into it to see exactly what the steps were and what the status and output is for each step. Now we've completed our GitHub portion. The next portion is to create a pull request and to have M0 run a Terraform plan. From the main repository page, we can see that it's letting me know there's a new branch, and if I want, I can create a pull request to merge the changes in that branch into main. So I'm going to create that pull request right now, and in the comments for the pull request, we'll see a checks area. And one of the checks has already passed, and that was the CI checking we did with the GitHub Actions. But it's also going to kick off a second check here, and that's the check that's going to run in M0. So let's see how that is configured now. Over in M0, I have an environment that is called Full Web App Testing, and I already have that environment deployed. Let's look at the configuration in M0 for this environment. Now, under Settings, I have it set up that it will redeploy on every push to the Git branch, and it's tracking the main branch. So when I merge a change into that main branch, it will run and apply. It's also going to run a Terraform plan only on pull requests to this branch, and I just opened a pull request against this branch, and so it ran a Terraform plan, including any actions that happen just after the Terraform plan. And I've defined a custom action inside of my code. Let's take a look at that code. Going back to GitHub, we can see that it is still in progress. So we'll go over to the actual code, and in the code, I have a file called m0.yaml. M0 looks for this file, and it will add some custom actions to the workflow when it finds this file. The important part here is that I'm installing Open Policy Agent as part of the workflow. That means I can run OPA against the projected plan that Terraform produces. And I do that by converting the plan file to a JSON file, and then evaluating that file against a Rego policy that I have defined also in the same repository. Now you can dig into the details on your own later, but the essential idea here is not only am I doing a static analysis of the code itself, I'm also doing analysis of the projected plan to make sure it's valid based off of policies I've defined before I actually merge this change into my main branch. Now let's take a look at that pull request and see how we're doing. I see a green check mark, which means that all checks have successfully passed. It was able to run a Terraform plan, and if I want to view the plan details, it's letting me know that it's going to add some tags to my public IP address, and that's it. If that looks good to me and I'm happy with that, as well as the OPA test results, then I can merge my pull request, and now it will make those changes to my testing environment, and I can safely delete this branch. All work is done. Or I can continue working on this branch to add tags to other resources. If we go back to M0, this deployment will trigger a new deployment on this environment that will update the environment to include the tag on that public IP address resource. In this video, we have seen the continuous integration process as it applies to infrastructure as code. We started at the workstation and running some pre-commit hooks to make sure our code was syntactically valid. Then we moved it up to the centralized repository on GitHub, where we did some trust but verify work to make sure the code looked syntactically good and also ran some policy checks against the code itself. And then once we created our pull request, we were able to do additional analysis and testing based off of the plan that Terraform generated. If you incorporate this into your existing IaC workflow, you'll get code that is more consistent, more dependable, and probably will have less unexpected changes. I hope you've enjoyed this video. Thank you so much for watching. If you want to find me, I'm Ned1313 on Twitter, or you can visit my website, nedinthecloud.com. Thanks again for watching. Until next time, stay healthy, stay safe out there. Bye for now.